You have the fast watch.
Like just explain it?
Well, and now I started winning.
Like
They're
they're
actually
I was thinking it so much.
No, that was my.
Yeah, that's.
Yeah, who's on his way?
He's late. He said on my way.
Like, yeah. Nope. Yeah. Watch out.
You're in the mile. You're only, I don't know if it's Thursday. You're in the mile and if he's in the mile and 2 miles. Wait, I know about there's 2 miles on the miles. I mean, there's 2 miles.
That's right.
There's one that was called like Super Strong. Oh, yeah. I have the regular name.
Oh, how was your fishing trip?
Oh, they put it the regular one. The Rising Star. Rising Star.
I was going to send it in the group chat on Sunday or whatever. Can you take? Can you
Look at it.
Yeah. Yeah. Remember when we asked you that?
Wait, is it in the same week?
What was the probability?
I don't know, probably. No, it is. And then I marked it on.
So this is a small one.
You might be.
And then we did it.
Really, because they're only the 2
This
miles.
is-
Everyone else is in 2. Maybe
Strike.
take my spot. Actually, I can probably run
Yeah.
easily, yeah.
I would take. So I ended up not eating it. Like Friday night. What's the point of going? I know this was terrible. So like we fished in the morning from like 6:25 until like 1,
Yeah, it's awesome.
and then
Yeah, it's better than
I ended up
that.
working all the rest of the day, like tearing off the deck. And my friend who was house we were at, he's putting on a huge.
I was going to, but then there was some 2 miles. Are you excited? I know, but I see everyone else.
Like,
Ava and Paige.
sort of the MO is you work all day long until like 8 o'clock, and you don't have dinner until like 10:30 or 11. Come on. So we had all that fish pushing, and we just shut out here.
I tried.
11. And
The time is up to this 10:21.
It's like 9:45.
Yeah. I think you're
And then
only
you
good.
eat.
I was like, I'm going to bed. I don't even feel like eating. Oh my gosh, come on. I was just not feeling it. I mean, I was, because I'd been up all day, I got up early the day before. Then I got to the house, it's a 5-hour drive, so I got there at 11 o'clock, 10 o'clock. I sat there and BS with it until midnight, then got up at 5:30. So, I didn't say good. No, they did. So I went
Well,
to
there's 2 separate. They might just combine it. There are a lot of.
But I've never had this. I've had all the other. I've had small ones. I've never had.
Yeah, it was all. There was like 10, 11, 13. Everywhere.
What? Jack.
I think George.
Yeah, keep the jack.
Maybe she'll run it.
Yeah.
I was gonna go. And then add. There's another add. Not rubber.
Are you going to the
Starts with a B.
New York? So, I think this morning during air testing, I was mapping out some stuff. And so I think that I can plan this if we on Wednesday. Wednesday the 5th. So if we were to do some sort of version of a class on next Wednesday, then the only 2 days we would have to come in after seniors are done would be to take our last test and to take the exam. So, right now I'm sort of shooting for Tuesday, May 11th to be that last test, and then the exam to be 2 days later. And I can be flexible with that. I don't know if you want more time, to study. Well,
We're talking.
yeah. I mean, oh wait, you're a senior. You get a vote. I think the seniors get the most vote. Now, the issue with the exam is I'm not going to be here that Friday. So if we didn't do it Friday the 14th or Thursday the 13th, we wouldn't be able to do it until the following Friday.
That's okay.
But I mean, I can be somewhat flexible with that. But I think I have it worked out. I mean, I was really trying to just cram everything. But I don't know that I want you to have to take your exam on your last day. And I don't want you to have to take your last test and then your exam. Back to back. Just don't know that that's. I feel like you'll be better off. So what do you seniors think about it? I don't know. I don't care what the seniors think.
Are we coming in Tuesday and Wednesday next week, or just?
Tuesday you can't come in. Tuesday I have meetings all day long, and I don't even know if we're supposed. I don't think you're supposed to be in the building on the voting day. It's like for your protection.
Exactly.
But I have meetings all day long on Tuesday. So were you putting on Tuesday? Is that what you were gonna ask? I saw that.
No, oh yeah, I was gonna ask, so is the exam over everything semester 1 and semester 2, or just semester 2?
It's just over semester 2, but obviously there's semester 1 stuff that,
Yeah.
I mean, if you don't know how to take a derivative, well,
I'm talking more of
that's kind of problematic.
Related rates?
Related race?
Related rates.
No, that's, no, I never, that's, okay, good. I could have guessed that's what you were talking about. If I would have heard you, yeah. No. Yeah. So it'll just, I mean, the exam is just gonna be really over all the integration techniques. Yeah, right. All the integration techniques, L'Hopital's rule, because I think that's technically a second semester topic. I need to verify that.
We have to do it on
We did it first semester.
We've been doing it now.
Hold on, I'll tell you. Nope, it's not, sorry. I stand corrected. So it would be over techniques of integration, area and volume, infinite series, and power series. So,
Are we gonna get like a?
I mean, really, just what we've done since we came back to school live. I mean, there's a whole unit that we're not doing. I mean, we're not doing the unit on parametric equations. Now, those kids that are taking Calc2 next year, we probably will. I'll probably teach that to them after you guys are gone, just kicking around in class. I mean, we won't take tests on or anything, but so if you go on and take Calc2, like parametric equations is kind of a big deal. So what are your thoughts about that? What do you think about that, Tom? Carrie, what do you think about that, Tom?
Good, sounds good.
You just don't care.
Yeah, I don't.
Annie, what do you think?
I mean, I don't really care.
Wait, so are we gonna, are those like the final dates for the test and the exam?
Not for sure, but that's kind of what I'm sort of shooting for.
I kind of want a little later.
What's the English AP?
That's fine.
Yeah,
That's
we have
what
one
you say?
the 13th.
Yeah, can we have it like a little later? Push it out of it.
You would rather have more of a gap and take the exam later?
I have an AP bio.
What day was the last test?
Right now, I had it as the last test being Tuesday, and then the exam being Thursday.
Would it be like?
May 11th?
May
11th.
Tuesday.
May 4th.
No subject. Three words.
Yeah, May 7th is 60 minutes.
Next week, yeah.
Next time.
May 4th is a week from today.
Yeah, I'm already off.
We're not here then.
I knew I wouldn't do it.
When are we taking?
What's May 4th? You guys listen. It's May 4th.
You said the 13th.
Oh, my hope, or my plan, or my wish, or my desire, or whatever you want to call it,
Aspirations.
is that we take our last test on May the 11th, Tuesday, May 11th, and then our exam 2 days later on Thursday, May 13th. But I could be flexible with that exam time. I wanted to try to get the seniors to done as quickly as I can. But at the same time, maybe you want more time before the last test and the exam.
I think our bio.
Yeah, AP bio test is.
Oh, wait.
It's May 13th.
I'm pretty sure.
What about that Monday? The Monday, the 17th?
Yeah, that's fine with me too.
Yeah, Monday, 17th.
I don't know.
Yeah, we got.
I mean, the chances of us all not having a contest. My schedule is probably the, somewhat most important in the sense that, I'm not going to give you the exam on the day I'm not here. I probably would give you a test on the day I'm not here, but not.
How long is the exam again?
Like the last one?
Yeah, it'll be like the last one. I mean, it'll take some people an hour, it'll take some people 2 hours.
Speed run.
Some people may never finish. Some people will still be working on it. There's someone working on it for 3 years ago right now. Yeah, I don't know. So,
If you look at right.
we're trying here.
Yeah, you have to get perfect for it.
Trying to be not a jerk, but also trying to not just throw in the towel and say, well, who cares if these kids learn anything? Who cares if they're getting credit from Wright State? I mean, I'm trying to find out.
Another question.
Yeah.
So, yesterday my English teacher told us that the grade doesn't carry over to college.
Yeah.
Is that true? Or
Just
is
the
it
credit.
just the credit?
credit, not the grade.
So it's going to depend on where you go to school. But in general, when you guys transfer a credit from one university to the next, in general, the grade does not go with you. Now, there could be exceptions to that. Obviously, if you end up attending Wright State, the grade's going with you, for sure. If you end up at a school in Ohio, it's possible the grade ends up going with you. But if you take the credit to a school or a private, I should say, if you end up at a public school in Ohio. But if you end up going to a private school in Ohio, or if you end up going out of state, I would say it's very likely that the grade. But you have to earn a C. Otherwise, they don't take transfer. So yeah, it is very possible that the grade. Are you in CCP English? So how did that come up?
She just, you said it here.
Her daughter was in and she.
Her daughter was in my class?
No, she didn't know.
Who are we talking about?
Miss Taylor.
Oh, yeah. So I think she's in women's class. Yeah. Yeah, and that's just, when I transferred from Butler my freshman year to Miami, none of my grades went with me.
How can we be sure about like your university?
Probably the easiest way to be sure would be to look at your university's transfer policy. So like if you're looking at their website, click on like transfer students and look to see what that says. You know, I actually made a video last spring that I'll probably just put on our Google Classroom that walks you through the process on how to go about transferring your credit from Wright State to wherever you're going. It's kind of a little bit of a process. So you just have to go through that process. So you got to request a transcript, an official transcript be sent to your new university. Then they have to evaluate it. This is what they call a tagged class. So if you're going to a public school in Ohio, it's automatic. It doesn't even have to be evaluated. But if you're going to a university that's like outside of the state of Ohio, or maybe a private school in Ohio, they might have to evaluate the transcript and say, oh, okay, so Abdel Karish took Math 2 or 2300 and 2310 from Wright State. What is that? And then they might say, okay, oh, that's Calc 1, Calc 2. That's going to be our such and such. And then we'll work it. Where are you going?
Ohio State.
Easy. That's easy.
But like, do you know if the grade?
I don't think at Ohio State it does.
Let's go. So these.
Now we know.
So does that change your answer about when we had the exam?
No, I still don't want it on the same day as my AP.
But
Actually, I wouldn't.
now the juniors care about that because, you know, that's their high school GPA is it's affected. I mean, this class is affecting seniors' high school GPA too, but it doesn't matter. So, all right. So you guys want to go over these homework problems? Did you do them? How did we do? Is it good? Yes. No. You want me to just go over all of them, or yeah? I'm not sure if there's any time we set in DS folks.
No. That was the only one that I didn't get it in.
I wrote it out.
You can give it a try.
I got that far. I didn't know what to do after that.
So that's the first one. This is number 13. Yeah. So the deal here is they wanted us to just find the radius of convergence, not the interval, just the radius. In fact, I think all of these were finding just the radius, which is kind of annoying, but that's okay. So we'll set up the ratio test. Right? So that ends up being 2x in the numerator, yeah? And then n over n plus 1. And then the absolute value of 2x will come out of there. You're left with this. And we need this to be less than 1, right? So we're going to find the values of x that are going to make that less than 1. So, well, this part is 1. So its absolute value of 2x is less than 1. So 2x is between negative 1 and 1. So x is between negative 1/2 and 1/2. So the radius is what? 1/2. Where's the center? 0. Okay, so the interval would be this, right? Now, technically speaking, we don't know if it converges at negative 1/2 or a positive 1/2. We would have to check. So how would you check that? You just plug it back into the original, right? Does it converge at negative 1/2? If I plug in, let's just do that real quick so you see that. Plug in negative 1/2, you get 2 times negative 1/2 to the n over n. That simplifies to what? That's just negative 1 to the n over n. Does that converge or diverge? Negative 1 to the n over n converges. It's alternating series, right? It's conditional, but it still converges. So then x equals positive 1/2. That ends up just being 1 over n, right? Positive 1 over n. Does that converge or diverge? That one diverges. So this one converges, this one diverges. So you actually will see this for the interval of convergence sometimes. You see it written like that? You seen that notation before? But they just ask for the radius on all these. So that's kind of weird. What's next? 14? I'm just going to set up the ratio test.
We did odds.
Oh. You did odds. So 15's next. So if I set up the ratio test, I'm going to get n plus 1, x to the n plus 1 over 2 to the n plus 1 times 2 to the n and x to the n. Right? So then, how's this going to simplify? Looks like x over 2, and then n plus 1, and n, right? So now if I pull that out of there, absolute value of x over 2 times the limit goes to infinity of n plus 1 over n, and we need that to be less than 1, right? So now we have the absolute value of x, because this right here is 1. So the absolute value of x over 2 is less than 1. Absolute value of x less than 2. Can you just look at that and tell me what the radius is? 2. So r equals 2. Woohoo! 17. Because we're having a class. Because we got stuff to do, man. These kids got a semester exam to take for Calc2 from Wright State. Okay. Look at these kids. They're all dedicated.
I don't know anybody looks thrilled.
Oh, they're thrilled. I'm thrilled.
I love it.
I mean, I get to hang out with these great people. I mean, it was fun sitting out there in the yard, though. That's where we eat lunch during the nice weather. We
It's nice outside. Sorry.
Yeah, we could just meet out and hang out outside. What's 17?
Hey, and it's senior skip week.
Week? We've extended this to the week now? Jeez, oh Pete. It's senior skip semester. None of these kids skipped on Monday. Did they? I don't think so.
Nobody had a cough or cold or anything.
They were all worried about getting booted out of NHS.
Nobody on their deathbed says I wish I'd spent more time at work. Whoever says I've never heard anybody say, man, I wish I'd spent promoting school.
That's true.
Other than math class, of course.
Heck yeah. There's nothing better than this. I mean, really, the only thing that we could be doing now better than this would be fishing.
Oh, yeah. Oh, yeah.
Did I set that up right? I got distracted. Let's see. And this, yes. Okay. So how this one simplifies almost just like the last one. Is it the exact same?
It's just squared.
Oh, wow. That's crazy. So everything's the exact same as the last one, except this is just a squared there, which is going to cause it to end up simplifying basically to the exact same thing. Carrie, is that what you just said? Yeah, I thought that's what I heard you say. So this is going to end up being x over 2 and n squared. So the absolute value of x over 2 times limit n goes to infinity of n plus 1 squared over n squared. Don't even really have to simplify that because you can compute the limit the way it is, right? So the absolute value of x over 2 times 1, we need that to be less than 1. So the same radius, right? Yo. Were you thrown off on number 19? Because of the K? Did that annoy you? Instead of N? You made it N? You're like, no, thank you. Whoops. Pi to the K. You'll see K used sometimes. Is that K to the pi? Gosh, that's annoying. Okay. All right, so we'll set up the ratio test here. So this is going to be pi to the K plus 1, x to the K plus 1, over K plus 1 to the pi, right? Times the reciprocal of the kth term. So that's going to be K to the pi over pi to the K, x to the K. I don't know why, but that is really weird looking. And it just feels weird even writing all of it. Even I had to really think about what I was writing. Okay, so now we're going to simplify this. So the x is x to the K plus 1, x to the K, that's just going to be x. Right? So now I've got pi to the K plus 1, pi to the K. That's just pi to the 1, right? And then I've got K to the pi over K plus 1 to the pi. So now what's going to come out of there? The absolute value of x times pi. Oh, I'm making this n. That's so funny. It's just habit. What should these be? Really k, right? It's just habit. K to the pi over k plus 1 to the pi. All right. So now you need that to be less than 1, right? Okay, what's this part right here doing? You're just thrown off because that exponent is pi. The variable is k, right? In the numerator, the exponent on k is pi. And in the denominator, the exponent on k is pi. So that's really just balance. So what's this going to? 1. So now you've got the absolute value of x times pi to be less than 1. So the absolute value of x is less than 1 over pi. So what's the radius? 1 over pi. It's a goofy answer, but it is the answer, I think. Oh. So who's next? 21? Finally, we have one that looks a little bit more involved. With some factorials at least. 10 to the n. X to the n over n factorial. So here we go. We'll set up the ratio test. It's 10 to the n plus 1, x to the n plus 1, n plus 1 factorial. And then we'll do the reciprocal of the nth term. So how's the 10's going to simplify? 10 to the 1. How are the x's going to simplify? X to the 1. That's going to be 10 x. And then n factorial over n plus 1 factorial is just going to simplify to n plus 1. So now I've got the absolute value of 10x times the limit as n goes to infinity. Actually, I should say the absolute 10 times the absolute value of x. Of 1 over n plus 1. And we need that to be less than 1. So what's that doing? It's going to 0. So this is 10 times the absolute value of x times 0 less than 1. So what's the radius? Infinity, all real numbers. $23? Ooh, this one's gonna have an. Oh, we're doing 23, not 22, right? Yeah. Oh, another k. So we have k factorial squared x to the k. 2k factorial. You ready? So we're going to set up the ratio test. So it'll be k plus 1 factorial times k plus 1 factorial. I like to just write these out. X to the k plus 1 over 2 times k plus 1 factorial. Then times the reciprocal of the kth term. So that'll be 2k factorial, k factorial times k factorial x to the k. So now you want to simplify, yeah? Ooh, okay, so I'm going to do one more step before we simplify. Well, I'm going to go ahead and simplify the x's. So I'll just put x to the 1. The bottom is 2k plus 2 factorial, yes? Oh, and I forgot these guys. Okay, so let's simplify these factorials. I'm going to pull the x out. So k plus 1 factorial over k factorial is k plus 1. K plus 1 factorial over k factorial is k plus 1. So we got k plus 1, k plus 1. And then 2k factorial over 2k plus 2 factorial. Well, over here I'm going to write this out. 2k plus 2 factorial is 2k plus 2 times 2k plus 1 times 2k factorial. So he'll cancel out with that guy, and you're going to be left with 2k plus 2 times 2k plus 1, right? And we need this to be less than 1. Whew. So what's this part right here going to be? Not 1. They've all been 1. I feel like all of them have been 1. So it's easy to just bite on 1. What do you say?
1/2.
What do you say?
Yeah. I don't know if you can do this, but can you take a 2 out of the 2k plus 2, make it k plus 1, and then simplify k plus 1 and k plus 1? If you know what I mean. So you'd have in the absolute value x over 2.
You can do all the legal algebra you want inside there. But that's not going to change the outcome of what the limit is.
But is that legal
Yeah.
algebra?
Oh, yeah. And you could factor out a 2 here. And so I have 2 times k plus 1. Cancel that with one of those. And you'll have this 2k plus 1. But you're still going to have 4k squared in the denominator. Or, well, if you cancel, you'll have 4k. You'll have k in the numerator and 4k in the denominator. So it'll still be 1/4. You following me? Following?
Yeah.
You sure? Because your eyes are not
I'll
telling
see
you.
it eventually.
Like, y'all, that could be you like 2 years from now, though. Like, still working on these. Like, so if you do what you want to do, because it's legit algebra. Right? That's what you want to do, right? So you're going to go, and then you're going to be left with this.
Okay, so you can't take the 2 out and put it like on x over 2. Oh,
But
it's
it's-
still at 1/10.
Yeah, you're still going to have that 2 that you have to reconcile. Like, yeah. So it'll be the x over 2 times 1/2. It's still going to end up being 1/4. Okay, so this is 1/4 times absolute value of x. And we need that to be less than 1. So the absolute value of x is less than 4. So what's our radius? 4. Okay. That one may have been one of the hardest ones that you had to do. I don't know. Ooh. That's incorrected. 25. Did you just look at that and just skip it? Well, thank God there's a factorial there. Okay, so I'm going to write this one down. So that's k factorial over 1 times 3 times 5 dot, 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 2k minus 1, right? X to the k. So first of all, do we understand what's going on in the denominator? If we don't understand what's going on in the denominator, we'll never be able to simplify this the right way. Talk to me.
Where's the x to the k? Is it like
The x to the k is, I mean, it's either in the numerator, if you want to put it in the numerator, or just stick it out here to the side. It doesn't matter. It's this times x to the k. But that's the same as putting it in the numerator. No, God no. Yeah, then it wouldn't be a power series. Think about that for a second. If it was 2 the x to the k, then it wouldn't be of that form where you just are going to have something times powers of x's. Okay, so what's going on in the numerator, or in the denominator? Like, depending on the value of k, you're going to have odd numbers being multiplied together there. So like when k equals 1, you'll just have 1. Let's write out the terms. Maybe this will help. So our first term when k equals 1 is going to be 1 factorial over 1, right? The 3 won't be here because, well, would the 3 be there? No, it will be, yeah. So what you said, what does this dot 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 mean? That means continue on this same pattern. So could be 1 times 3 times 5, and then dot, dot, dot. Like when k equals 1, you're done, because k equals 1 is just going to be 1. When you plug in k equals 1 there, you're just going to get 1, right? I don't think that's what they meant. I don't know if they meant it this way. Let's keep going. So then x to the first. Then what's the second term? 2 factorial over 1 times 3 times 5 times 2 times 2 is 4, right? Times 3 is 3. X squared. So do you see where I got this? I'm plugging in k equals 2. So I have 1 times 3 times 5, and then times k equals, when k equals 2, that's a 3, right? You guys are looking confused.
The dot, dot, dot is just.
Yeah, where did the
Yeah,
dot?
why'd they do that?
Did they just keep going? Why?
Is there still a dot?
It's saying keep this pattern up.
So would there be a dot times 7 times?
So it wouldn't be, yeah. Doesn't it just keep going? We just skip this. We're never gonna see this.
It's like throwing in the top. I wish I had a solutions guy, because I'm not 100% sure that they don't actually mean 1 times 3 times 5 times 7 times 9, like all of them.
That's what I was thinking.
What's your
Is
question?
it being multiplied by the synchronous one, or is that just
That's the pattern.
Yeah.
the pattern?
I don't know. I'm not 100% sure. Because if it's just the pattern, then this wouldn't be here. This first one would just be 1. This first one would be, this one would be 3. Then the next one would be, you know what I mean? But to me, it looks like those are multiplied because those have dots next to them. You know what I mean? Like the 1, 3, and the 5 have a dot. So it's not just indicating that the denominator is those things, it's the product of those things. And to me, I think in order for it to simplify, think about this for a second. What's in the numerator? K factorial, right? What's in the denominator? It's basically K factorial, but only odds. It's like removing all the even numbers out of the factorial. I think that's what they were intending. You guys follow what I'm saying there? And because I don't have a solutions manual, I don't know exactly what they were intending, but I think that's what they were intending. What is the answer to this? Is it 0? I mean infinity?
It's 1/2.
It says 1/2 is the answer.
I didn't get that.
It says the radius is 2.
Oh, it says 2.
Thanks, guys.
Yeah, it says.
Ooh, I'm not sure how they would have gotten that one.
It shows it like it shows.
Well, you don't have the worked out answers.
Well, it in the answer that you give us.
What? Will we have to wait 10 years?
Yeah.
Billy's got it on his phone. Let me see.
I'm good with ratio.
the word back.
Oh, wait, it does say.
What?
It probably should.
Yeah, I want to skip that one because I'm not sure how they got there. Yeah, I just read it.
Because I got really close trying to do it in class.
You're not gonna do that to us.
No, gosh.
Or exam, or
He can't even work it out.
That's gonna be all the problem.
Any answer we put down, he's like, yeah, look at those curveballs.
I want to make sure.
I like that.
I'll work this out when you guys leave. I'll work this out the way I thought it was, which is not. I don't think it's going to get two.
You can try.
And if that's it, then I'll do it tomorrow. What?
I got, no, I didn't get it. I don't know what that was.
Well,
I got it.
Yeah.
I'll even take it. Or talk about it. So what's 29? You want to do that one?
Yeah.
Can we do that one?
Oh, wait.
Yes.
So we'll come back to this. I want to do some investigating. I'm not going to give you one like that. I don't want you to have to decipher all of that. You can believe me. This one's going to be infinity. I'm pretty sure it is. What? It's not? Oh. Well, all right, let's do it. I'm glad I'm not guessing here. Okay, so we'll set up the ratio test, right? So this will be n plus 1 factorial, n plus 1 factorial, n plus 1 factorial, right? X to the n plus 1 over 3 times n plus 1 factorial, right? Times the reciprocal of the nth term, which is going to be 3n factorial over n factorial, n factorial, n factorial, x to the n. This one's very similar in structure to number 23. There's just one more factor that you got to worry about. So x to the n plus 1, that's going to be absolute value of x, which I'll just go ahead and take that out of there. So n plus 1, like that's this and that will simplify to n plus 1. This and that will simplify to n plus 1. This and that will simplify to n plus 1. So we'll have n plus 1 cubed. Do it that way, just because I'm running out of room. Times 3n factorial. And 3n plus 1 there is going to be 3n plus 3 times 3n plus 2 times 3n plus 1 times 3n factorial. So we need this to be less than 1, yeah? We're going downhill a little bit here. So these cancels. So I have the absolute value of x times the limit as n goes to infinity of n plus 1 cubed over 3n plus 3, 3n plus 2, 3n plus 1. Colin. This is you.
It's gonna be x over 27.
Right. You guys see that? Because this is basically balanced. The coefficient on the numerator is 1n cubed. And the coefficient on the denominator is going to end up being 3n, 3n, 3n is 27n cubed. So the absolute value of x over 27 less than 1. Absolute value of x is less than 27. So the radius is 27. That's a big radius. It's not as big as infinity, right? So does that help, hurt? Did you get all those right? Except that number 23 or 25? Yeah.
So will these have a one that doesn't center around 0?
None of these did they?
Yeah.
Do any of them in this section?
And then we didn't do them on the notes either.
The example that we started off with was the only one, wasn't it? Yeah. I mean, we'll have some of those at the end of the, so here's the plan. So now we know, what a power series is. We know how to find a radius of convergence, determining what values of x are going to make that converge. The next phase of this, and this will happen on Thursday, I'm going to show you some power series that actually are equal to functions that you already know. Now, you've already had exposure to two of these. The one for sine, we did that a while back, and the one for e to the x, which I told you in class the other day. But there's one for cosine, there's one for tangent, there's one for natural log. And so then we're going to spend time saying, okay, well, now that we have a little package, a little drawer full of series, you can create new series for functions from the existing ones. For example, if you know the series for e to the x, then you can make a series for e to the x squared. If you know the series for sine of x, you can make a series for x squared times sine of x. You can do combinations. So I call that building new series from existing series. We're going to spend some time doing that. And then the last thing that we're going to do is learn the formula on how you can build a series for anything. It's where all this stuff came from. Yeah.
Do we have anything to do tomorrow? Or
I don't think so. No. We're going to have a quiz on this interval of convergence or radius of convergence. We'll do that probably on Friday. But yeah, I don't think we have anything to do tomorrow. Because I think if you can do any of these, you can pretty much do any of the ones that we're doing. You guys know Mr. Grace? What brings you here?
I just wanted to know what all these awesome people are here doing.
So you came in with a different approach than Mr. Renshaw.
What did he say?
He was just bullying them for being here.
Really?
I think many of them might have felt victimized.
I mean, it's major nerd alert, but I'm all for it.
It's isn't it senior skip week? Apparently now it's weeks.
Yeah. I thought every Wednesday was senior school day.
Right, weekend Wednesday. That's why Maddie asked, are we gonna have any, wait, who asked are we gonna have any tomorrow? So you or she wants her day off. I gotta have my relaxation time.
Not cool.
Really?
Nope. Yeah.
That is Brian Boyd.
Right?
What's he doing here?
Who the heck is Ryan?
He's a professor.
Is he a
at
doctor?
State.
Yeah, I make that part of
No.
Good enough. Hey, Brian.
Hey, how's the wife? How's the kid? How's it hanging, Brian? All right, well, I'll see you in a minute. Why is it so long? I have a dead mark.
I told you.